Hello and welcome back. We are going to talk about two things in this screencast: hearing and the other senses. I guess the other senses is a whole section. First of all, audition is the sense of hearing, so that's a definition, pretty straightforward. Frequency and pitch are two terms you're going to have to understand. Frequency is the number of complete wavelengths that pass a point in a given time. So sort of when you have this wavelength going along, how many of those pass at a certain point in time is frequency, so it would be sort of speed. Pitch, a tone's highness or lowness. It depends on the frequency, so that's how you get your pitch. Okay, and as far as the what does that really mean? Just know what those definitions are. You don't need to know, be able to pick out what we're talking about, like on a picture or something, of what a pitch is or something. All right, now we have the intensity of some common sounds. So now we're talking about audible, or decibels. Okay, and you can see there, I don't have to read it all to you, but a whisper is very low. And actually, you can hear below a whisper, of course, that's the threshold for hearing. And then when you get all the way up to like a rock band amplified at close range in a concert, that is not good. So, and the big thing here in the text they really push is prolonged exposure above 85 decibels produces hearing loss. It started with actually the generation before mine, where they started finding people who had gone to all these concerts back in the 60s and 70s and they weren't protected. They're going deaf at younger and younger ages than previously in the past, and having to have the hearing aids and all that stuff just a part of their life. I think people understand it better today. I don't know if the youth of the world cares as much. Everybody feels like they're impenetrable or unbreakable. But I know you can put your headphones in and raise basically the decibel level enough that it will cause hearing damage. So be careful. I'm a caring teacher. All right, here is basically the picture of the ear. It's in the book. I'm not going to go through every single thing here, but you have the outer ear, and they show you here. I'll use my little handy-dandy pointer here. The outer ear is this whole section here. Your middle ear is here, and your inner ear is here. Okay, and it connects when eventually the part of the ear that turns into an auditory nerve. It connects to the auditory cortex and the temporal lobe. Pretty cool. Okay, so the outer ear, this disc-shaped thing that is on the outside of our heads. Some of us have. See, I got a relatively normal-looking one there, and this one is kind of not the most normal-looking ear, but that's okay. It's my ear, and I'm not giving it back. But basically, the only reason these exist is to catch sound. It's a dish, basically. Then you have the canal, which funnels the sound into the ear. And then you get to the middle ear, where you get all the conductor bones that will pass along that information, the stirrup, hammer, and anvil. And I'm guessing they get these names because it reminded somebody of a stirrup, anvil, and hammer. All right, and then you eventually get the sound to go into the cochlea. And inside here is where you have all these little tiny hairs, okay? And it is this hair that basically that moves, that detects the intensity of a sound, the pitch of a sound, and so on and so forth, so that it can get converted into an electrical signal for your brain to interpret. Okay, let me see if I can. All right, here you have the middle ear, chamber between eardrum and cochlea, containing 3 tiny bones. I already talked about that, so you got that. The inner ear, innermost part of the ear, should be containing the cochlea, semicircular canals, and vestibular sacs. As far as that goes, let me see something here. Your semicircular canals are really big on your balance. They tend to be filled with fluid. You need it to stay fluid. severe dehydration can cause you to lose your balance. Heck, it can actually, it throws you into vertigo, I guess you could say. So does like a lot of drinking alcohol. People talk about the bed spins, where more or less you are, sitting in a bed. You've had so much alcohol to drink, it feels like you're sitting on a bed that's spinning around. I'm always having trouble with my hands where to put them. But that'll work. Yeah. Now, they're also important for just walking around, but you can have some genetic problems. I have them. I get vertigo very easily. Roller coasters are not something for me that is enjoyable. I didn't really understand that till I got older. But my fluids in my semicircular canals don't seem to work the same way as most people's, and so when the roller coaster makes movements that I'm not prepared for, I can't keep up with it. It's absolutely terrifying for me. It's not fun at all. Okay, and I used to go on roller coasters because everybody was going on them, and hey, you don't want to be the one guy who wusses out or something. I thought everybody was going through these emotions, these experiences I was having. I didn't realize it was much more fun for people until I started looking into it and realizing, oh, they're not experiencing the same thing I am. So I'm not just a girly man who doesn't want to go on the roller coaster. It's extremely upsetting. I get sick, nauseous, and at the same time, I feel like I'm going to fall out of the roller coaster constantly. So it's just terrifying. All right, enough about that. All right, and then you get the cochlea, which is the coiled, bony, fluid-filled tube in the inner ear through which something happens. Why don't I have the rest of that definition on there? I'm going to pause for a moment. Okay, basically, make a long story short here, it's basically, like I said before, where the hair is, that it just sits out here and it's just waiting for vibrations in the air, and it may vibrate more than normal or less, and that is interpreted as signals by your inner ear. And we'll explain all that here in a little more detail. We have two ways of theories of explaining how you hear. You have place theory and frequency theory. We are not absolutely sure about all of it. We just, again, theories are, what's most accepted at the time until somebody disproves it. So go with it. So place, the theory that links the pitch we hear with the place where the cochlear membrane is stimulated. So depending on where you are, if I'm showing you this curve here, basically you'll hear you're gonna hear sounds differently here than you would hear, and if it's stimulated up here, so you have the little hair flowing right here. If that hair gets stimulated, that's where the signal will be sent to the brain through here, so that the place that's stimulated on the cochlea matters. Now, frequency is different. The theory that the rate of nerve impulses traveling up the auditory nerve matches the frequency of tone, thus enabling us to sense its pitch. So what that's saying is you've got this curve here of this cochlear implant, or cochlea, and basically it's saying that with all these little hairs that would be on here, the number of them, the frequency of vibration. So if more of them start vibrating, that's going to send different signals. Less or more will send different signals to your brain telling you what pitch you're hearing. So those are the two different theories. All right, how we locate sound. This is pretty cool. If you notice, we have two eyes that give us binocular view, so they're offset so that we can see depth real well. We have two ears because it helps us locate sounds well. It's a survival technique. It's something that's built into us to help us survive. We don't have one ear right here in the middle of our forehead, mostly because dating would be very difficult. I crack myself up. All right, no, that's not why. It has to do with that sound travels at a certain speed, and you can see here in the picture, air from this bell is going to hit the right ear faster, just a bit faster. Doesn't have to be much because your brain can detect the difference. It's going to hit it's going to hit the ear on the right faster than the left ear, which will allow us to locate that bell faster. Okay, so we'll know, hey, something's coming from this ear faster, so we'll start turning in that direction, figuring it's got to be coming from that direction, if that makes sense. Okay, and again, I always use the example of like a sniper. One reason why it's such a big deal in the military to have a sniper who can hit its target with one shot and then basically get one kill, as they say. Because when you're not ready for a sound to come at you and it suddenly is just like a gunshot, you don't have enough time to move your head to figure out where did it come from. So it sounds like the shot came from everywhere, and it gets very, very confusing for those who, of course, did not want the person to be shot to find you. If you have to take a second shot, now everybody's ready for it, and everybody's tilting, when you're trying to listen for something. Notice whenever someone says something to you and you're like, do you hear that sound? We all tend to tilt our head a certain way because it allows us to focus one ear on the sound being made and increase the angle so we can locate it faster. So again, it's important if you're going to become a sniper. If not, just use the example for what it's worth. All right, we have two types of hearing loss. You can have conduction hearing loss and nerve hearing loss. Conduction is hearing loss caused by damage to the mechanical system that conducts sound waves to the cochlea. So that could be like things with the eardrum, the stirrup, anvil, hammer. Those type of things can cause a problem. Nerve hearing loss is caused by damage to the cochlea's receptor cells or to the auditory nerve. So that would be like the hair. And this is where they say when you get enough damage done to the hair in the inner ear, it will lay down. And once that hair lays down, it doesn't come back up, and you lose hearing, your ability to hear. And so two different ways to lose your hearing. These are just some, this is just an example of the fact that when you're listening to things over the course of your life, wait. Oh, I'm sorry. You tend to lose your ability to hear higher frequency sounds. This is where you guys like to pull out that stupid program on your phones and say, hey, can you hear this? And I'm like, no, I can't hear it, because I guess over time I'm old enough now, there's certain things I can't hear that you guys at your age can hear. Don't worry, Father Time is coming for you all. Father Time, undefeated. Undefeated. Don't forget that. So it does get worse as you get older and you hear things not quite as well. All right, moving on to the other senses. Touch. I like this one. Okay. Composed of 4 sensations or senses. You have warmth, pain, pressure, and cold. That's how touch is determined. Okay. The only one that has anything that we've actually figured out as far as an identifiable receptor site is pressure. We actually have points on our body where if you push, we actually understand why we feel that. There are things in our skin and our muscles that allow our brain to register, hey, something's pushing on me there. The other 3, we're not so sure about. Okay. Just combinations here of things. When you have warmth plus cold, it means it's hot. So it's interesting. Okay. I never would have thought of some of these things myself. When you have pressure, something's pushing on you, as well as cold, you think it's wet. So think of what water feels like when you get in it. It's pushing on you because you got all that water around you, and it is actually wet. You can actually mimic that by laying down on a cold metal table. It will feel like a little like you're wet. Okay. So then if you have pressure and pain, it's like a tickle itch. So if again, I'm just using my hand a lot here, sorry. So if you just do one of these things, and this is kind of like, there's a little bit of pain. It's not a ton of pain. Obviously nobody feels this and goes, it's not like that. It's just that there's pressure, and there's the sensation, it's the lowest level, like very lowest level of pain, you're going to get a tickle. And it's irritating. If it's done enough, it irritates you. Okay, it's not comfortable. All right. So gate control theory has to do with pain, and this is basically the idea that our spinal column is filled with a series of gates that either allow pain to pass through and send the signal up to your brain, or it'll block pain signals. Okay, a gate can be opened by the activity of pain signals traveling up the small nerve fibers, or it can be closed. Okay, it's like the severity of the pain. Sometimes something happens, kind of like, you ever notice how sometimes maybe you get you bump into something, you don't realize you bumped into it, and then you get a bruise, and you're thinking, where did I get that? I don't even remember how I got that bruise. Well, the thinking would be that the sensation that was created by the bump was not strong enough to power its way through all the gates to get to your brain, so you would go, ah! Now, we've all done, the same thing where we stub a toe at night, where you get up, you're walking around, and that little pinky toe just finds some piece of wood or something, a chair or something, bam! Now, that shoots that pain all the way up to your brain, okay? It's strong enough, even though on a, as far as things go with pain, it is not the worst pain you probably have ever felt in your life, but at the time, it may feel like that. And I guess you could say that aspirin, Advil, they're starting to help you block these gates, okay, so that they don't open, so that you don't feel pain. Now, one thing is you cannot feel pain and pressure at the same time. That's why there's the instinct that when you stub your toe, the first thing you want to go to, one of the ways to turn off the gates, okay, so bam, you hit your toe, the gate opens up, pain, 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 we instinctively grab for our toe and we rub it. Oh, okay, we don't even think about it, we're rubbing it, because whenever we rub it, what's happening is we are shutting off gates that send signals of pain to our brain, so that, just to understand, basically, you cannot feel pain and pressure at the same time. So the rubbing is a way that we instinctively do to reduce our pain. One other thing before I move on, I want to talk about phantom limb syndrome. It's a weird thing to wrap your brain around. Think in terms of if I chop off one of my fingers, okay, boom. I'll feel pain. I won't, I'll be in pain. But the part that's causing pain is the nerve endings that are remaining in my hand. The part of the finger that I chop off and throw away, and if it's gone, okay, that part that is gone, that's not feeling pain. That little piece of a finger, there's no pain being registered anymore by the finger. The finger's not in pain because it's not connected to a brain. This part of my body is feeling the pain. And basically what we've got here is, for whatever reason, these nerve endings in a missing limb continue to acknowledge, one, they're there going, oh, well, the finger's still completed, and there's things going on there, okay? And so they're sending signals still up the arm to the brain saying, oh, now we have an itch, or, oh, bang, you banged your finger on something, go grab it, okay? Now take that and amplify it if you are, cut off your arm. And so if you're missing a whole arm, you have all these nerve endings right here that are still thinking, hey, there's supposed to be an arm at the end of this, and they're still firing, doing their job, sending signals to the brain. And so you might have these nights where it's not unheard of, people who lose limbs, they'll sit up in the middle of the night and scream because they feel a pain in their arm that is not there, which, you got to just, we don't understand it perfectly. I think if we did understand it better, we would be able to help these people better. But it's just part of losing a limb. The brain is not necessarily always like, oh, it's gone, so therefore I don't need to register anymore use those nerve endings that are still attached to the body anymore. That's not how it works. Okay, moving on. Now we're at taste. Basically, you got sweet, sour, salty, bitter. I don't think that's anything new. I can tell you that, guys. the principle that one sense may influence another is sensory interaction. So you understand that when you walk into a house and you smell something baking, that deep, that aroma hits you, that influences how you taste something. Okay, it's very difficult for us to eat something that we think smells badly. There are lots of things out there you can eat that won't hurt you, that don't smell particularly good. So the fact that smell and taste work together is sensory interaction. Okay. All right. So I got that. That's pretty straightforward. Smell. All right. All right. Smell. Just basically, it's little particles, little molecules that are floating through the air of a substance that our nose is wired with these little what do they call them? Olfactory receptor cells, little hairs, okay, that pick up these molecules, and they send a message to the brain saying, hey, there's something in the air. There's something you might want to eat, or maybe it's a gas leak or something. You can smell those things, and as you get more experience, you're able to locate in your mind what that might be. Smell and memory are very, very closely related. I don't know if it's because they're very close to one another in the brain. Could be that, or something else. But smells, when you have smells that maybe you haven't smelled in a long time, and suddenly it hits you, it's going to bring you back to memories of many times when you're a kid, or sometime prior in your life when you're like, this makes me feel like, hanging out in my grandma's kitchen, or something like that when I was a little kid. Almost done. All right, and again here we have the reduction in sense of smell as you age. It's not uncommon. Women tend to have a better sense of smell than men. Maybe that's why they like flowers so much better. But I can tell you that it definitely does happen. My mother, who is an animal lover, I think she has 3 dogs now and 4 cats, 5 cats, I don't know. And then whatever dead animals those cats bring into the house. I can tell you there have been times I've walked into her house and gone, "Whoo, oh, what's that smell?" And usually it smells like something died. And my mom won't realize that there's a bad smell. I don't know if she's adapted to it over time or not, but we look around for a little while and we find some mouse or bird that's been decapitated, and it's like, well, that's a dead, rotting animal sitting in our house. And so I can verify that this does happen. I'm sure it's coming from me. I'm not making fun of my mom, but it's just trying to give you an example. All right, body position. It's kinesthesis. This is your ability to know where you are in space. Okay. Why do I know that my hand is here? Now, many of you are saying, because your eyes are open, Demi. Okay, I know you are. Not really. It's more of a kinesthetic has to do with they found all these receptors in our skin, our muscles, that send signals constantly to our brain to tell us where our limbs are in space, even without eyesight. So, why can I touch my nose with my finger without having my eyes open? Because my kinesthetic sense is allowing me to do that. You can actually have that messed up, where of course then you're going to have all kinds of problems keeping yourself in an upright position, or not tripping over yourself or whatever. All right, a vestibular sense is the sense of the body movement and position, including the sense of balance. Again, this is the fluids in the semicircular canal, and when this goes, you can fall over fairly easily. This is your sense of balance. And you do not want to lose your vestibular sense because it is what allows you to put yourself in the most advantageous state on 2 feet that human beings like to prefer to defend themselves or go out and interact with the environment. And that is the end of this chapter. So I hope this helps. Talk to me if you have any questions. Good luck. Talk to you soon.